Hi guys, so this video is to explain to you what half-life is in a little bit more detail and to show you how to do some practice problems when you have to calculate things about radioactive substances. So the definition of half-life, which you read about in one of your assignments last week, it's the amount of time it takes for half of a sample of radioactive material to decay. So you know that if something is radioactive, its nucleus will get rid of particles to try to turn into something more stable. So let's say I had 100 atoms, it would be how much time it takes for 50 of them to turn into something else. And different substances have different half-lives, and you can actually look up the half-life of different substances in your reference table on table N. So you guys used this table last week when you did transmutations. If you look at the second column, it's titled half-life. So this chart tells you how long it would take for half of these substances to all decay. And notice that they all have different units. So some of these decay in a matter of seconds, some take minutes, some take days, some take years. So it's important that you pay attention to the unit and not just the number. Okay, so let's see how to do a problem. This is the easiest type of problem you'll get where they actually tell you how many half-lives went by. So what I always do to solve a half-life problem is I set up a chart. And the first column is the number of half-lives. And then the second column depends on what the question is asking. So see how they give me 400 grams? Grams is a mass. So I'm going to call this second column mass. Okay? So at time 0, none of my sample started to decay yet. I have my full sample, so I have 400 grams. Now, however many half-lives went by, that's how you want to number your half-life column. So the question's telling me that 3 half-lives went by, so I would label this column 0, 1, 2, 3. Every time one half-life goes by, half of the mass decays. So what's 400 cut in half? 200. When another half-life goes by, that gets cut in half. So what's 200 cut in half? 100. And when my third half-life goes by, we get cut in half one more time. So 100 cut in half is 50 grams. So that's all you have to do there is set up your chart for how many half-lives and keep cutting the mass in half until you get to the bottom of the chart. Okay, so I want you guys to pause the video and I want you to try number 2 on your own. When you're done watching the video, you can pull up the filled in version of this sheet and you can check your answers. So pause the video, do number 2. Okay, number 3 gets a little more complicated because if you read number 3, it doesn't tell you how many half-lives went by. It tells you what your mass is, and it tells you the total number of days that went by. So if I know the total number of days that went by, and I also know the half-life of radon-222, I can figure out how many half-lives went by. So I'd want to take that number, 3.823 days, and I want to see how many times it goes into 15.28. So if you guys don't have a calculator out yet, you should definitely get a calculator. We're going to divide these two numbers. Okay, and I get 3.99. Your number of half-lives should always be a whole number. So 3.99, I could round up to 4. Okay, so now I'm back to the problem that I did before. I can set up my chart. I have my half-life column, my mass column. This time, 4 half-lives went by. So I would want to start, I always start this column at 0, but then I want to number it down to 4. Okay. I started with 100 grams, and then what happens every time a half-life goes by? The mass gets cut in half, so I'd want to cut 100 in half. Then I'd want to cut 50 in half. Then I would cut 25 in half, and then I'd cut 12.5 in half. And I would end up with 6.25 grams. So for here, when they give you the total time like that, they do that in this question too. You want to look up the half-life of that element, see how many times it goes into that total time, and that's going to help you fill out your half-life column. So again, pause the video, try number 4 by yourself. It's the same as question number 3. And then once the video is done, you can go check your answer key. Number 5, so this one again is a little bit different. It's similar to number 3 in that they gave me a total time. So if I know how much total time went by, I can go to table N. Okay, so the half-life of carbon-14 is 5,715 years. So if I divide that by 5,715 years, I get, let's see, 22,920 divided by 5715. So I get 4. So 4 half-lives went by, right? So I'm going to set up my chart. 0, 1, 2, 3, 4. Now, this question is different because they don't give me the mass of carbon that I started with. They're asking me for fraction. So forget about half-life for a minute. Let's say I have a box of pizza, right? So before anybody takes a slice, I have 8 pieces out of 8 pieces left in my pie, right? So if I give you that fraction, 8 out of 8, how would you simplify that? 1. So anytime you're at time 0, that means none of the sample has started to decay yet, so you always have 1 full sample left. Okay, so we're going to title this chart fraction instead of mass because the question's not about mass. The rest of it, you do the same exact way. You cut your numbers in half until you get down to 4, except you want to write your numbers in a fraction. So what is 1 cut in half? 1 half. If I cut a half in half, I get a quarter. If I cut a quarter in half, I get an eighth. And if I cut eighth in half, I get 1/16. So after 4 half-lives, 1/16 of my sample would remain. The biggest I've seen them go is 5 half-lives. So notice that the denominator keeps multiplying by 2. If you ever get a question where 5 half-lives go by, my fraction would be 1/32. And that's the furthest I've ever seen them go with fractions. Okay, so if you guys can pause this, try number 6. It's similar to number 5. Okay, let's look at question number 7. So how this question is different is they're not telling us what the sample is. So if I don't know what the sample is, I can't look on table N for its half-life because I don't know what it is. So for this question, we're actually solving for half-life. You still want to go about doing your chart and just filling in whatever you can. So I'm going to do 1 column half-life. I see grams given to me in the question, so I know my other column should be mass. They could give you fraction too, and you can title that column fraction. That really wouldn't make a difference. Okay, so I know that I'm starting with 100 grams of a sample, and I know that I ended at 12.5 grams. So basically you want to just cut this in half until you get down to 12.5 grams. So now that I have this column filled out, can I fill out my half-life column? Absolutely. When I have 100 grams, that means no time went by. And then how many times did I cut it in half after that? 1, 2, 3 times. So I know that it took 99 years for 3 half-lives to go by. So how would I figure out how long it took for 1 half-life to go by? I would see how many times 3 goes into 99. And I would get 33 years. Okay. Number 8 is similar to number 7, if you can give that a try. All right, number 9. So looking at number 9, how much phosphorus 32 did you start with? So now this 10 grams that they gave us, that's what we ended with after it got cut in half however many times. They want to know what we started with. So again, guys, they're giving us the total amount of time that went by. If I know the total amount of time that went by, I can figure out how many half-lives went by. So phosphorus is 14.28. So 42.84 divided by 14.28. 42.84 divided by 14.28. Okay, so I get that 3 half-lives went by, right? Set up my chart. They're giving me grams, so my other column is going to be mass. 3 half-lives went by, 0, 1, 2, 3. So how is this going to be different? If I ended with 10 grams, I have to put that 10 down here. Now to go down a chart, I have to cut the masses in half. What do you think we'd have to do to go up a chart? We'd have to double it. So we started with 80 grams. Okay. Okay. Number 11, that's the last one actually. You guys can try number 10 on your own, so pause the video right now, give it a try. Okay, so number 11, this is the last type of question you can get as far as half-life goes. Here they want to know how old an object is. So far our answers have been like in mass or in grams or in fractions. Here, like, you want to think of what the half-life is and say how old it is. So it's going to be like a unit of time. So it depends on what they give you. For this question, they're giving us a fraction. So when I set up my chart, I want to have a half-life column and a fraction column. Okay. Now, they're not telling us how much time went by. So I can't really like look up cesium-137 and figure out how many half-lives went by yet, but I could use that fraction. What does my fraction column always start with? It always starts at 1. I have the whole sample still there. I'm going to cut this in half until I get down to 1/8. Now that my fraction column is done, I can go ahead and fill out my half-life column. So that 1/8 told me that 3 half-lives went by. So if I look up cesium-137, 1 half-life is 30.2 years. So how long would it take for 3 half-lives to go by? So 3 times 30.2 is 90.6 years. Okay, so that's pretty much it, guys. If you can now pause it and try number 12. I'm going to post this whole worksheet filled in, so after you tried them yourself, you can go check the answer key. Then you have some CASEL learning to do, and a lab to do for this week, and a review assignment. Okay, have a good day.